study basin strata, to look at the shelf margin, and to look at the back shelf as well. Now this part's eroded away. We don't get to see the evaporites back here. We see a little bit, but not much. But the whole idea is to walk through the strata and look at processes in the basin along the shelf margin, and then look at back shelf, these are big carbonate ramps down here, those processes, and then when you turn into a rimmed margin, what these processes look like here, and how you create reservoir potential for conventional reservoirs here and unconventional reservoirs out here that are actually mixed in with some conventional reservoirs out here as well, like Brushy Canyon turbidite fans of sand versus Wolfcamp shale and Bone Spring shale, other material like that. So that's the whole idea for coming out to this part of the world, is because what you see back here is actually mirrored in the subsurface in the Permian Basin. So if you find the right place, you find perfect analogs to the same stratigraphic interval. That's the beauty of this part of the world. So the Guadalupe Mountains and the outcrops of the Delaware Basin are textbook examples of what's in the subsurface, and it's a natural laboratory. And then you can apply some of this elsewhere in the world too, for a bigger analog. That's the second neat part about this whole area. But that's kind of it in a nutshell, why we come out here, other than to get away from the office or get out of the house and stuff like that. So.
And Bob, in the few days we've spent together, one of the great appreciations that you've shared with us is how you take all of this and apply it to real problems in the subsurface.
Yes.
You looking at fields, doing the detailed event cycles, doing the sequence stratigraphy. What do you call it? Analytical?
Yeah, well, process sedimentology.
Process sedimentology, and measuring very detailed sections, correlating the detailed sections, because flow units matter in oil fields.
And so you can do regional sequence stratigraphy on the large scale, or you can zoom into an oil field and do reservoir scale work. And not just sequence stratigraphy, but porosity evolution, and then you try to find the connectivity of all the packages, and if one tends to water out, say this one, during a water flood, you isolate it, and then you just put water through the next most porous and permeable intervals like this, and if one of them does the same thing, you get rid of him, and you just keep doing this process, and it's called conformance. And that really helps the reservoir engineering group on a really fine scale. So there's both exploration scale and development scale potential out here looking at these outcrops.
And as we look at the world's greatest basins, of which the Permian Basin is the prototype, onshore, let's get it in there, Super Basin.
Yeah.
There are lessons here that can be applied, as you mentioned, globally.
Yeah.
So great outdoor classroom, great connection to the subsurface, and then the bigger picture, what can we take away? Oh, and do you want to say a word about Raz and the late tilt? Because that's a special thing here.
Yeah, because when you take a look at this whole area right here, instead of looking like this, it's actually tilted like that. And it went all the way back to El Paso, Texas. And so there's this huge area that brought a lot of water in to the shelf margin. And if you have connected debris flows, have actually pushed water down into the connected debris flows into the basin facies. And then some of the water has actually got into faults and fractures. And when they have moved, they've created this enormous amount of pressure that has actually injected some of the water into the source rocks and creates this weird looking stuff we call calcite beef. Because if you can get fluid inclusions in it, it tells you it's fresh water and it was hot. So it's also part of the ROZ story too. And the neat thing about this area is you had this huge recharge area, and then it rifted and pulled apart. So where the water had pushed the oil out of a structural closure, a lot of those closures had the chance, when that head of pressure went away, to resaturate and partially or completely refill up with mobile oil. And then a lot of them only partially filled up and left an ROZ at the base, but those actually resaturated a little bit, so the upper part of the ROZ is a play. So you come in and horizontal them and drop the pressure, and the mobile oil will start to migrate into the horizontal. It's really neat.
So getting more oil out of big fields that have already been found.
Yeah.
And development geology is very critical. We think at a big scale, but we got to look at the development scale.
Mm-hmm.
And so one of the things that's amazing to me is the great canyons out here. And because this is a pretty dry area, you don't have that much vegetation.
No,
so
great
boy, if you wanted
exposures.
to see cuts, three-dimensional cuts into
This
the
is the
geometries.
place. Yeah.
So classic canyons,
Yeah.
connecting it all,
Yeah.
good stuff.
Otherwise, you couldn't do this.
Yeah.
You couldn't do that. You couldn't create these models, you know. And this is one that Charlie Cairns did. He gets all the credit in the world for this. And it's a great one to put on the front cover, because you see the basin, the margin, and the back shelf.
Great.
It is perfect, you know.
Well, thank you, Bob. We've really enjoyed our time together.
It's my pleasure.
It's great to be with you.
Thanks.